In this lesson, we're going to have a look at the differences between passing information through input and output interfaces on a function block, and then passing the same data through an in-out interface. So we have two blocks here. One is not using an in-out interface, and you can see that we're passing the alarm data into an alarm group input and then to an alarm group output. And then down here, we have another one that's exactly the same, except for we are passing the alarm data through an in-out interface. And for those who don't know the difference between input, output, and in-out interfaces, inputs will copy the data from here, so whatever variable you have on the outside of the block, and then it will copy it into the internal variable, in this case called alarm group input. And then when it comes to the output, you will copy the information from the output, so alarm group output, it will be copied and will overwrite the value in alarm data.a1. So these are the same variable, but we're copying from the outside to the instance data of the block on the alarm group input, and then we do all the processing and whatever it is we want to do, and then we do the alarm group output and copy it from the instance data out to alarm data A1 again. So everything is stored inside this data block here. So if I was to go and have a look at the definition for this data block, we can see that we are at this level here. So at the offset of byte 4, we then have our alarm group data. So we can see that it starts at 4, and then we have an array of 0 to 255 of Boolean, twice, one for our alarms and one for our accepted signals. And we have the same again here. So it's quite a big variable. The UDT makes up quite a number of bytes, and we have it in this instance data twice. So we can see that our last offset for our memory is 134 bytes. Now, this is with optimized data turned off because it better demonstrates our problem here, or demonstrates how the memory is managed. If you had optimized data turned on, you would have a small saving potentially, but for the purposes of showing you the offset, I've turned off optimized data. So let's have a look at how that compares with the in-out pointer. So in this particular example, we have our alarm data again, but this time it's on the alarm group in-out. So if I hover over here, sorry, Tia Portal's doing its thing where it's not showing tooltips. If I hover over this alarm group here, we get in-out UDT alarm group. And if I just go and have a look at the data block for this this instance here, we get a slightly different picture to what we saw on the previous data block. So I'm just going to pull them up side by side. So first off, we have less to work with. This side we obviously have the alarm group twice, once there and once there. We only have it once here, but you'll also notice we can't expand it here. We can't have a look at the data. And you'll also notice that it's only 6 bytes long. So it starts on offset 6, and the placeholder in the static is at 12, whereas the placeholder in the static on the in-out, so input and output, where we're copying data, is at 134, making this block much bigger. And the reason for that is when you use in-outs, they are pointers. So if we go back to the previous block, this here is a pointer. We're making a reference to alarm data. So I'll show you with some actual data because it makes it a little bit easier to demonstrate. But if I go and open this block here, and I'll just split the screen again so we can see stuff on this side, and we'll have a look at index 90 on the alarm block. If I come down to 90 and then monitor, we can see we are false at the moment. So we're looking at this line here. This is enabled and ready to go. So if I say, let's set the alarm, so modify that to a 1, we see that the alarm goes true. If I then turn that off, modify to a 0, it should stay true until we hit the reset. So modify to a 1, that resets. So the block is doing what it's supposed to do. If I then swap the enable over to look at our pointer example, whoops, I should have turned that off, not on. Make that mistake all the time. So now we're running on this one. We're looking at alarm 91 on this one. And I do exactly the same. Modify to a 1, it goes true. Turn that off again, modify to a 0. And then I do the same to reset it. That should go to a false, which it does. So there's no difference in how these blocks are working with the data, except for there is a slight difference. So this one here is copying the data, remember. So we're working with the instance data. So let's switch this one back on and let's go in and have a look at the block in action. So if I open a monitor, what we can see in here is that if the set input is on, then we set the alarm group output. Here we're doing a check on the alarm group input to say if it's already set, then set the alarm active. If we do reset, then we reset the output alarm, like what we're sending out. Now, it's important to understand what's happening. This is a really basic example, but because we're doing copying, you need to make sure that what you're copying, you copy, make the changes that you want to change, and then output it. So we're doing things here like we're saying set the alarm output, and then we're doing a check on the input, so the data that came in, to see if that's already set, so we can say the alarm is active. The problem here is it's going to take more than one scan to make this check, because what we're doing is we're setting the output, and then we've got to come out of the block, process an entire cycle of the PLC, so the next time we pass information into the block, that input is set. So when we actually do this check on this scan, that alarm active won't be true, even though we've just set the alarm output, because we're working with instance data. And by the time we do this check here on the alarm group input, we've already received the data from the outside before we've made the change. So just bear that in mind whilst we have a look at the InOut pointer example. With this one, it's slightly different because when we do the set, we set the alarm group and the index number. So we set the Boolean alarm. And then when we do this check here, because it's reference data, it has changed already. That instruction has executed, it's updated the data that we are referencing. So this one would be true. So if you were to go and run both of these at the same time on different groups, because if you run them on the same time, at the same time, you're going to run into issues with the blocks fighting each other because they're referencing and copying information to the same place. But if you were to run both of these with no crossover of information, you would see that the alarm active for this block where we are using referencing and pointers and in-out interfaces would update on the same scan, but the copy block wouldn't. And it is an important thing to understand, because especially when you start getting into the realms of doing things like one-shot latching or pulses and things like that, you might find that if you switch to the in-out method, that things that you would have done previously may behave differently, because now you are reading things that you have immediately updated. So it is a slightly different way of thinking. There are advantages of doing the in-out method. Personally, I prefer it, and that's because of the noticeable size difference of the blocks. I say noticeable. If you actually come and have a look at the program info, and have a look at the size of the blocks. So FBs, these bottom two blocks here, there isn't a great deal of difference. I will just, we haven't made any changes. That's fine. I will just refresh it just in case. But there isn't a great deal of difference in our sizes. So the in-out, where we're not doing where we're not doing pointers, is slightly bigger, both in the load memory and in the work memory. And the in-out pointer, where we are using the in-out interface, is slightly smaller. But we've only got 3 lines of code, and we're not really dealing with a great deal of data. So when you start having big structures, like for all of your different assets, or a system that comes together out of lots of different assets and they're all bundled into one big UDT, passing by reference through an in-out interface makes a big difference. Like not only on your load on your CPU for load memory and the codework memory, but CPU speed, all of that stuff, it all comes as a cost of copying that information all the time. And yeah, it is something that you need to bear in mind when going down this this approach. It's far better to use in-out than to copy on inputs and then copy again on the outputs. So from here in, you'll see that all of the asset data is always passed by in-outs. Basically, anything that's a structure, anything that's more than one variable, and in some cases, even just a single boolean might be passed as in-out because it's beneficial to do that because of how we're interacting with the data inside the function block. But as normal, if you have any questions about this topic, then let me know. There is, if you search for in-out, as in the interface in-out, on this site, there are some other posts that sort of go into this detail as well, but they don't go any further than what I've already explained here. But if you do have any questions, let me know, and just bear this stuff in mind as we go further on into the course.